Hello friends, so in this video I am going to cover a course review of a mechanical engineering course, and this is the course of mechanics of solid, or it is also sometimes called as strength of material in some other universities. So this is in a series of videos I had already given reviews on heat transfer, applied thermodynamics, manufacturing process. So let's continue with this. So in this course, you are going to study about the truss. Hence, I have highlighted the truss of it. So let's start with this. So in this video, I'm going to cover the major topics which we will study in this course. Some of the study resources I'll mention which I used. So it may be wrong to say major resources, but some of the resources which you can use. Then I'll explain the evaluation scheme used in our university and the field of application or some other related subjects to strength of material or mechanics of solid. So usually mechanics of solid is abbreviated as MOS, and in some other colleges it is also said as strength of material or SOM. So if you are going to prepare for GATE or some other competitive exam, you may find the course name as SOM, which is strength of materials. Don't get confused, it is same. Then so are there any prerequisites? So basically the professor would expectedly start from basics, understanding the vectors, understanding force, moment, the couple, etc. If not, if he skips this and directly starts from the concepts coming up in this course, then you should go back to understand what are the basic trigonometric properties which will be helpful when you solve numericals. Then you should revise the concepts of vector, then force and moment. And for force and moment, you should also consider and get thorough with the directions, because when the couple comes, the couple is a coupling force. So if that comes, there the direction may get confused. In terms of rotational vectors, also the direction you may get confused. So get thorough with those things. Other than that, it's all fine. Then so mechanics of solid is a base for manufacturing also, and it's base for design. It's more for a base for design engineering part. And if you have less clarity about what in which domain it will fall, do check my video on the domains, various domains of mechanical engineering. There you will get the complete picture of where the mechanics of solid would fall under the complete branching of mechanical engineering curriculum. There is a lot of theory involved, but obviously in the professor or in exams, you will not be asked to jot down the theory or recall theory. You will be asked to solve numericals. So further apart from theory, you should go on and practice numericals as and when concepts are taught, as and when theories are taught in the class. And numericals would usually be simplified from a practical situation. But if you find the course interested, then you would quickly think, or your brain will automatically start thinking where you can apply the concepts of mechanics of solid to solve practical situation problems. And this can appear when you are passing some bridge, a railway bridge where the truss is involved, where beams are involved, etc. Also in that situation, if everything is incorporated, all the concepts are brought in, you can easily understand how the bridge is designed. So overall the course is very easy, but at some point of time there are multiple concepts involved, and also there are multiple formulas available to solve a single situation. So you should have a clarity that based on what values you are given, what type of formula you should use to get your desired result. So the major topics involved in this course would be the basic theory of mechanics, which you would have studied in 11th and 12th grade physics. If sir doesn't revise this, you are expected to revise this. Okay. This is also the very basic, the equilibrium and non-equilibrium situation, and force and moment concepts, and along with that the vector concept. Then definitely the sir would start from stress and strain. So it's a very interesting things. There are equations developed from basics. So sir would derive equations and can give you the final equation and giving relation between material properties, stress and strain. And it is very interesting to learn this and understand and apply in the real life situation also. Then you can go into stress strain temperature relationship. So this is an interesting thing, further one step ahead of stress and strain relation, where the effect of temperature can be studied. So if we heat the object, we know it is going to expand, and if we cool down the object, it is going to contract. So the expansion and contraction are involved with change of temperature, and that change of temperature is also going to give a change in strain or change in stress. Residual stress will be involved. So this is also an interesting subject. Then you may study torsion. So where we are going to provide torque to the shaft. So we'll understand the deflection, force, moment, and energy thing, energy equation. Same with the bending. So bending happens with the beam, and we can also understand buckling, which happens with the column. So that's all we have. So torsion, bending, and buckling happens with beams. But when we are going to apply a torsional force, it is called as shaft, which is a cylinder. When the bending happens, or when we apply a longitudinal force, and when it bends, it is called as a beam. And the same thing when it is having a tension or a compression force, to be correct, when we apply a compression force to the cylinder, it is called as a column, and it is undergoing buckling. So the same part, a same cylinder, when under torsion, is called as shaft. When under longitudinal force, it is called as beam, and when under compression, it is called as it is called as column. So three different names, three different forces for the same cylinder. Then some of the resources which I used. So the lectures were beautifully arranged for me, and they are useful because it is not as easy to understand everything from the textbook. Reading things and understanding figures make it tough. Then definitely the slides are uh, very beautifully arranged, and all the details are there in available in the slides, and also there are some example questions solved for you to understand things and how to solve numericals. Then the textbook is useful to solve different questions. So end of chapter exercise and example questions should be solved to get good marks. And in evaluation, so usually professor would take surprise quiz after a chapter ends. So if there are 5 chapters, usually he'll take surprise quizzes after the ending of first 3 chapters in the classroom. So be ready immediately. So if you have studied everything and if you attended classes regularly, sincerely solved example questions happening in the class, then the surprise quiz will be very easy for you. So you did not worry about that. It is only it's only like an attendance. So it's the question is very easy. If you are present, you will get good marks. The professor was Kiran Mali sir. So he is very good professor. He solves examples. He solves textbook questions also very well. So if you have any queries, do approach him. He'll give you very good response. And some fields related to this are design engineering, as I said earlier, manufacturing sciences also, and uh, ahead of this. So if you get interested in mechanics of solid, you would get interested in advanced mechanics of solid. And previously, if you have learned material science, manufacturing process, machine design, those are related, very closely related fields. So you will enjoy learning these things also, vibration, computer aided design. And if you have options to choose uh, things or courses related to this, so if you get interested on MOS, then you can choose fracture mechanics, mechanical equipment design, control system. Okay. And if you have any queries, do come up in comment, and the course handout will be available in the course description. Next, we'll go with the advanced mechanics of solid in the next video. Okay. Thank you.